ChatGPT did help me to figure out the difference between Minitab version of output versus the Excel one. I'm talking about the binomial distribution, where this is the Minitab version for attribute agreement analysis. It says that the mean value is 90% with the confidence interval goes from 73 all the way to 97. But I was getting the different answer here in the Excel, where I was trying to do the same, exactly the same formula, tradition formula I did use, and I was getting the different one. The proportion is 27 divided by 30 is 90%, and the z value is 1.9. These are all more of a normal distribution one, but I'm trying to insert inside the binomial distribution. I was ended up getting 0.79 and then 1.01, which can be assumed as 1 because the proportion value, the p value will always will be between 0 to 1, right? So that we can do that. And this is the question I was asking Minitab, I mean ChatGPT, that Minitab has calculated correctly the confidence interval for binomial. The same I tried replicating it in Excel, but I'm getting the different answer. So I've given two print shot, I handed over, and then it has given the answer. So you are running into a method mismatch and not a max mistake. Minitab is doing the right thing for binomial proportion, while you Excel you're using that normal one approximately, which breaks badly, especially near 0 and hundreds and all that. And then this is what I was using it in my calculation: p bar plus or minus z into p bar 1 minus p bar and n, which works better for the normal one, everything, when you have a symmetrical shape and all that. And it assumes that it is symmetry, it assumes that is a normality, is more of driven from the p bar and so on, right? So more from the normal symmetrical one. So Excel is not wrong mechanically, it is just using the wrong statistical model, right? So it still is encouraging Excel also as well. So the what Minitab is using the method called Wilson method, which helps to calculate, and the value shouldn't be never exceed 0 to 1. And then it also says that handle cases like 30 to 30. If number of cases 30 and all 30 is correct, then 100%. So, and when you calculate the upper quartile, I mean upper confidence interval, it might end up showing 1 or 2, 1 or 3. That theoretically it is not possible, right? So then it is telling that wherever that values are there, like 100, then it is telling like 1, right? And then it is, this is the formula. I find that this formula a little complex to apply in Excel, and then Excel has given me that Clopper Pearson method, beta dot inverse alpha. Alpha is your confidence interval, like 0.05, and 95% is confidence. K is the number of success, n is a sample, and then this is what it is, and then you do that. So now still there is, you will get the very close answer, but still because actually if it is 100, no, in this case of this one, you will end up getting the slightly over 1, right? So how to get it up? So Excel has, I mean, ChatGPT also has helped me to give that also as well. Let me show you that also as well. And this is a very complex formula. I'm just skipping it actually. So, but I will directly go to this formula, and which is the same formula like what we have seen before. But only thing is, it adds in the lower bound. It adds that if the value is 0, and b2 in this case, b2 is the k value, number of success. Number of success b2 is actually, like in this case, 0, then it is instead of returning 0. If b2 is 100, and right away, I mean, n, for example, n is number of sample have taken 20, all 20 are correct, so that means it is k equal to 100, right? So k is also 100. Sorry, 20 divided by 20 is 100, right? So in this case, I can straight away go for 1 instead of returning any beyond 1 value, right? It has also given that nice formula of this also as well, right? And with that, so the same formula I did apply here, and I could get that easily here. So you can see here, let me show you that same thing in the Excel. So in the Excel, you can see here, number of sample is 30, and then you have a number of cases 27. That means, so you have that how much percentage you will get it is that. So if you look at 27 divided by, and then you get this one, right? So you get 90%, right? So the average is that 90%. We will call it as the average. So 90% exactly the same thing. And what I'm doing it is actually, so 93 percentage for 1 and 2 are same. And then appraiser 3 is having, I'm just magnifying this one. I'll just keep it here. I'll come back to this later. Okay, so now you see that exactly it is coming the same 93 and then you have 100, right? And what is the pretty fascinating part for me is that this formula exactly I'm getting the same 73.471, and which Minitab is a base for me because Minitab is given very super accurate answer. The same thing I'm able to achieve through Excel also as well. So the formula is actually like the formula is quite straightforward. So what we are saying is that first, let me start with the beta formula, beta dot inverse, and then I'm saying that alpha value. So alpha is this one divided by 2, right? This is a standard formula. And then this is a probability, right? So whatever this thing is there, and alpha divided by 2. So then it asks for the k value. K value is, in my case, this is the 1 k value, comma, and n minus k. N, you have a n minus k plus 1. This is the formula, and then I'm entering it. So you can see the same formula. So, and I can just apply here also. I will end up getting the same thing, 77.926. And okay, now only the condition I'm adding it, if that value, if in this case I'm just adding that value, if that E5, that is k value, if E5 value is equal to, in this case it is not equal to 0. If it is equal to 0, I'm just asking Excel to return as 0 straight away, right? We don't need to do any analysis because actually if number of sample been taken 30, all 30 went wrong, then straight away 0, right? So it is still given that, right? Similar, same concept on the upper side, what I'm doing it, pretty same formula, but only thing is here I'm just adding it like 1 minus alpha by 2, and then k plus 1, and then you have that c4 minus c5, that is k minus n, right? So here I can add, for example, if I think that you can just see here, in this case is already 100, right? So it will definitely go beyond 100, right? So in this case, what I can do, I can just add same formula, but I can add, if this value is equal to this value, then it is 100%, right? So, and my upper bound as well as the confidence level upper will be the same, right? So I'm just returning 1. So it has given 1, that is 100%. I hope you find it useful and pretty detailed discussion on the binomial, but I hope you find this very useful. Thank you so much.